Hello and welcome to another video. This is Cracking the Cryptic app Fog of War pack puzzle number 39. The rules are: Fog of War. Correctly placed digits clear the fog around them. Classic. Every row, column, and box must have all numbers from 1 to 9 exactly once. Battenburg. A checkerboard Battenburg dot marks a 2x2 square of cells where the top left and bottom right cells are both even or both odd, and the top right and bottom left cells are the opposite. All possible dots are marked. That is very important. So let's start by quickly selecting all cells in the grid, and we're going to fill them with their possible values. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have a lot of digits already visible, so we have to spend some time just cleaning things up a little bit and removing stuff from the notes where we know that those numbers cannot show up. So number 2 cannot show up in this box or in this row. And same for number 4 right here. All right, so since this is a Battenburg, we know and we see that this cell is in the bottom right most corner of the Battenburg. Then since this is an odd number, this also has to be an odd number. So it therefore cannot be 2, 4, 6, or an 8. And these two are therefore even numbers of the Battenburg square. So they have to be not 3, 5, 7, or 9. So they're 2, 4, 6, or an 8. And since this is also a Battenburg, which this little gray icon shows us, then therefore since this is odd, this also has to be odd, so it cannot be 2, 4, 6, or an 8, and then these two have to be even, so this cannot be 3, 5, 7, or a 9. Perfect. And now, this is also a Battenburg, and since this is even, then this also has to be even, cannot be 1, 3, 5, 7, 9, and these two now have to be odd, so they cannot be 2, 4, 6, or an 8. And the only place left for the number 2 in this box is in fact right here. And this now reveals some new digits that we have to just manually clear from the notes. So no 6 over here, and no number 7 anywhere here. All right. Now look at this. This is number 6. It goes here in this box. That's the only place for it. But this 6 is even, while this cell right here is odd. Let's start coloring odd numbers with the green color and even numbers with the red color. So let's assume that this cell right here is even. Since it's on a Battenburg, this one would have to be even as well. And therefore these two would have to be odd. However, since this is even, and this is even, and this is odd, and this is odd, this would have to be a Battenburg. But all possible cells that have a Battenburg are already marked. Therefore, this assumption that this cell right here is even leads to a contradiction. So, since it's not even, it has to be odd. Therefore, it's not 4, 6, or an 8. And since it's on a Battenburg, then this is also odd. And then these two have to be even. So this cannot be 3, 5, 7, or a 9. All right. Now, this is also a Battenburg. And since this is even, and this is odd, let's assume that this cell right here is odd. Well, since this is a Battenburg, then this is also odd. And now these two would have to be even. But since this is even, and this is even, this is odd by assumption, and this is odd, then this would have to be a Battenburg, but it's not. Because we see that there is, from this cell, we see that it's not a Battenburg. It would have to have a little square in the bottom left corner. So therefore, the assumption that this is odd leads to a contradiction. It is therefore even. So this cannot be 3, 5, 7, or 9. So it is therefore the number 8. And now this also has to be even, so it cannot be 3, 5, 7, 9, or the number 1, and these two cannot contain 2 or 4, and so they are both odd. Now this has to be the number 4, and since this is even, this cannot have the number 1. They both have to be even. All right. I think that takes care of a lot of stuff actually. So these are odd, these are even. What else? What can we do? Let's go through the digits maybe. See if maybe, maybe something opened up. That's the number 2. Nothing really on it. Number 4. 6. And then lastly, well, we do see that number 8 in this box has to go down here somewhere, meaning that none of this can be the number 8. Therefore, this is the number 2, and then this is the number 4. And that reveals the number 3 over here. And so we can clean things up from the notes. So number 3 cannot show up there. And now that leaves us with a 5, 9. So we cannot have a 5 or a 9 in the same box or row, giving us the number 7. And that reveals a new number, which is the number 5 over here. So this cannot be the number 5, leaving us with a 3, 9 pair. So you cannot have a 3 or a 9 anywhere here, giving us the number 7. And now we have a 1, 8 pair, meaning that this is the number 3, and number 1 cannot be here. All right. So since this is even, and this is a Battenburg, this also has to be even. So this cannot be 1, 7, or a 9, and this has to be odd, so it cannot be 2, 6, or an 8. Now, furthermore, look at these cells. Can this number be the number 5? If that was a 5, then this would have to be the 8. But then these two would be odd, these two would be even, and this would be a Battenburg, which is a contradiction because there are no indications that this is a Battenburg. So therefore, this is the number 8, and then this is the number 5. Furthermore, if this is a number 8, then this is the number 1. And then both of these would be even, and both of these would be odd. So this would be a Battenburg, which is in fact another contradiction, meaning that this is the number 1, and so this is the number 8. So that reveals some new digits. Namely, we have a 9, and we have the 3. Okay, so this has to be the number 1, meaning that this is the number 7. And placing the number 1 did reveal some new stuff. It revealed the number 9 and the number 3. So number 9 isn't here, and number 3 isn't anywhere over there. Okay, let's keep going. This is the number 5, and this is the number 9. This is a 1, and then this is the 9. Pretty good. Now, this is an even number. These two are odd, so if this was an even number, this would be a Battenburg. Therefore, this has to be an odd number, and it is therefore the number 5. Okay. This is a Battenburg. This is even, meaning that this cannot be a 7. And so this cannot be a 2, 6, or an 8, so this is the number 7. And now this also has to be odd, so it cannot be 2, 6, or an 8. Okay. Making some good progress here. Now, let's ask the question, can this be the number 7. If that was the number 7, you would not have number 7 anywhere else in the same box. And now these two are odd, and these two would be even, which is another Battenburg. Therefore, this is not the number 7. And so the only square left for the number 7 is here in the center. Okay. So let's just go through the digits very quickly, see if maybe something simple opens up. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I guess we're not that lucky. Okay. What else can we do? Maybe over here. Maybe this is what we should be looking at. Can this be the number 6? Well, if that's a 6, these two are even, right? This is an odd number, so if this was an odd number, this would be a Battenburg. Therefore, this cannot be an odd number, so it cannot be 1 or a 5 or a 6, because 6 was already placed. And now 2 and 6 would be up here, meaning that this would be an empty square. Therefore, this cannot be the number 6, and it therefore must be the number 1. All right. Now, we see number 5 is over here somewhere. 2, 6 and 2, 6 are over here. So that's a pair, meaning that we don't have 2 or 6 anywhere else. And now this must be the number 4. Okay, and that reveals another digit, that reveals the number 3. Now we have 6, 8 pair. So we don't have a 6 or an 8 here, meaning that this is a 9, and then this is the 1. And so this is an 8, 6, 8. Pretty good. What else? So this is odd, this is even. I don't think we can do that yet. Maybe over here, this is even. So this is even and this is odd. So if this was a 5, yeah, so if this is a 5, let's just assume that this is odd. So if this is odd, then this is odd because that's a Battenburg. Then these two would be even, right? But if this is even, and these two would be odd, meaning that this would be a Battenburg. And that is not the case. Therefore, so that means that that's a contradiction, because these two would have to be both odd and these would be even. So this cannot be an odd number, so that is not the number 5. And number 5 has to show up here in this box, meaning that it's right over here. So these two are even, and this has to be the odd number, so it cannot be 2, 4, 6, or an 8. And now we have 2, 6, 2, 6, meaning that this is a 4, and then this is the 8. Okay. What else? We have a 2, 6 pair over here, so you cannot have a 6 or a 2 up there. And we also have a 1, 2, 3 triple, but that's already clean. Okay. Maybe go through the digits again. Maybe we get lucky and we don't have to think. Number 2 doesn't look like it. Number 3, number 4. Oh, number 9 is here. And then number 3 is over here. So 1, 5, 1, 5. That's already clean. Let's go again. So 3, 4, and then 5, 6, 7, 8, 9. Okay, so nothing. That's okay. So maybe these, if this was an odd number, yeah, so these are both even, right? So if this was an odd number, that would give you a Battenburg. Therefore, this cannot be an odd number. It therefore must be a number 2. Okay, so did that open anything up? Not really. I guess it kind of shows us that this is also a Battenburg up there. But we don't know enough to reason about it yet. Okay. So 4, 1, 5, 4, 5. This is a Battenburg, and then here 3, 9, 6, 1, 5, 7. This is odd. This is also odd. Maybe here. So let's assume that this is an odd number. If this is an odd number, then this is an odd number, and then these two would be even. But these two would be even, and then these two would be odd. So this would be a Battenburg, and it's not. Therefore, this cannot be an odd number, so this cannot be the number 9. So these two are even, and therefore this cannot be a 3, 7, meaning that this is a number 6. And now this cannot be a 9, and these numbers cannot have a 4, 6, or an 8. And so this is the number 9. Okay. Now this must be the number 3, and that reveals some more information. Namely, you cannot have a 4 or a 5 anywhere. And that gives us a 1, 8, 5, 4. Now this is 4, 6, 3, 1, 7, 3, 8, 9, 7, 5, 7, 1, 9, 6, 8, and then 2. And so this is a 2, 6, 2, 6, 2, and lastly 6. Hope you guys enjoyed this video, and see you in the next one.